Hey there! If you're new to factories, plants, or engineering and feel lost with diagrams, this 5-minute video is for you. Have you ever looked at a P&ID and thought, this is impossible? The secret is you're not supposed to start with the P&ID. In oil and gas, we read diagrams like a ladder, from simple to detailed. We'll explain 3 key process diagrams: BFD, PFD, and P&ID. Why only these 3? In process engineering, there are many diagrams, like utility flow diagrams for power lines, piping isometric drawing, UFD utility flow diagram, plot plan, instrument loop diagram, hookup, cause and effect, C&E, logic diagram, ESD, emergency shutdown, FGS, fire and gas system, many diagrams. I will explain in more detail in the next videos. First, block flow diagram, or BFD, the easiest one. Think of it like a rough sketch of the process story, only the main parts. Example, in making orange juice, block 1, oranges in, to block 2, juicing, to block 3, juice out. Technically, a BFD uses blocks to represent major process steps and arrows to show material flows. A block could be crude distillation, reformer, or hydrotreating. The arrows show the main flow direction, feed in, products out, and the overall sequence of the process. In the atmospheric distillation process, crude oil is fed into the distillation tower, fractionator, where it is separated into various fractions based on their boiling points. The process yields the following products: overheads, vapors or naphtha, kerosene as the upper side stream, LAGO or light gas oil as the intermediate side stream, HAGO or heavy gas oil as the lower side stream, and atmospheric residue as the tower bottoms. A BFD is mainly used in early conceptual design to outline the overall process. It shows inputs, outputs, and sequence, but it does not show equipment details, tag numbers, valves, or instruments. To summarize the BFD, here are the key points to remember. What BFD is for, and for an operator, BFD helps you getting the big picture of the process, understanding how units connect, explaining the plant to beginners. What BFD does not show: no detailed equipment, no valves, instruments, or line numbers. Second, PFD, process flow diagram. Now we move one level deeper. A PFD shows the main equipment and main process streams. You'll typically see major items like pumps, heat exchangers, separators, columns, and compressors. You also see stream information, sometimes flow rate, temperature, pressure, or composition, depending on the company standard. In engineering terms, PFD includes major equipment symbols, pumps, heaters, main piping lines, flow directions, and basic data like temperatures, line number, or rates. It supports material and energy balances in basic design, but skips minor lines or instruments. In my upcoming videos, I'll be sharing the meanings of PFD symbols so that even complete beginners can read and understand the process. Remember to subscribe and follow my channel. To wrap up the PFD section, here are the key takeaways you should remember. For an operator, PFD helps you understand the normal flow path through the unit, identify key equipment in the process sequence, see what goes where during normal operation. But a PFD still does not show everything. Usually not every valve, not every instrument detail, not all drains, vents, and bypasses. Finally, piping and instrumentation diagram, or P&ID. Now that we have covered block diagrams and process flow diagrams, PFDs, let's dive deeper into the process with the piping and instrumentation diagram, P&ID. As you can see, this is a real-world example of a P&ID. A P&ID provides a wealth of detail, from feed sources and block valves to control valve types, instrument loop, control loop, interrock, ESD. You will find comprehensive piping specifications, including line sizing, materials, pressure classes, and insulation types, as well as details on blinds and their types. Furthermore, it includes technical specs for pumps, towers, and drums, along with their specific sizing. Crucially, it lists both operating and design conditions, such as temperature and pressure, PSV. All of this information is vital for operators to fully understand the technology and equipment, whether they are monitoring from the DCS or working on the operation site. This is the diagram operators live with. A P&ID shows piping details, line numbers, sizes, spec breaks, insulation, blind, valves, manual valves, check valves, control valves, isolation valves, instruments, pressure, temperature, flow, level, like PT, TT, FT, LT, control loop, safety devices, PSV, rupture disc, vents, drains, equipments like drum, tower, heat exchanger, pump, reactor, furnace, and connections to control systems, depending on the drawing style. For operators, the P&ID is the action map. When you do lineup, startup, shutdown, draining, venting, isolations, or troubleshooting, you use the P&ID. It tells you exactly what is installed and where it is installed. And there is so much more. In the upcoming parts, we will dive deep into every single detail to ensure you can fully interpret everything a P&ID has to show us. BFD for overview, PFD for equipment flows, P&ID for everything. We focus on these because they layer up simply from concept to reality, making learning easy and practical for everyone. Got it? Like and subscribe for more. Next, P&ID symbols. Thanks for watching.